In this video, we are going to check this piecewise defined function for continuity at 0. So we want to determine if f is continuous at 0. So what we want to do is check the three conditions. So first off, the condition that we check, condition number 1 is f defined at 0, or does f of 0 exist? And if we look here, right, this piecewise defined function, if we want to plug in 0, this is the condition, right? If I plugged in 0 for x, I would get a true statement, right? And so therefore, f of 0 is going to be equal to 1 over here. So condition 1 is satisfied. The next condition, right, is to take a look at the two-sided limit. Just like in the previous example here, we have a different formula on the left side of 0 than we do on the right side of 0. Right, and so what we're going to have to do is take the limit from the left and the limit from the right. So let's start off with the limit from the left. If we are on the left side of 0, right, then we would be less than 0. So this condition would be satisfied. Therefore, we would be using this formula right here. So I'd get e to the minus x is the formula that we would be using. And when we plug in a 0 for x, right, that would just simplify to e to the 0, which is equal to 1. Okay, so the limit from the left is equal to 1. Next up, we would have to take a look at the limit as x goes to 0 from the right, of f of x. And if we are to the right of 0 on the number line, then we would be bigger than 0, right? And so this condition would be satisfied. Therefore, we would use this function right here, 1 plus the inverse tangent of x. So we would take the limit as x goes to 0 of the inverse 1 plus the inverse tangent of x. Right, and so that's one of the ones that we talked about where you can just evaluate the limit by plugging in. In other words, that it's the inverse tan function is continuous everywhere. Right, and so we would get the tan inverse of 0, right, would just be 0. So we'd get 0 plus 1, which just comes out to be 1. So what that says is that the two-sided limit exists, right, and is equal to 1. Okay. So finally, we need to check the third condition, right? And the third condition is asking, is f of 0, right, the value that you got from plugging in 0, is that the same as the two-sided limit, right? And just to be clear, right, both the one-sided limits were equal to 1, right? And so therefore the two-sided limit is equal to 1. And also f of 0 came out to be 1. So in this case, condition 3 is satisfied. F of 0, in other words, the number that we got from part 1, right, condition 1, is the same as the two-sided limit that we got from part 2. So that means that condition 3 is satisfied. In fact, all three conditions are satisfied, and if all three conditions are satisfied, the conclusion is that f is continuous at that number.